Dear students, in this lecture we will discuss how we can accept a string with the help of PDA. So there are two ways to accept a string. One way is through final state, another way is through empty stack. So I have written here there are two ways. One is by final state and another is by empty stack. So for final state, let the PDA is M and it is represented by 7 tuple, that is Q sigma to del Q0 Z0 F. Then the language accepted by this machine M can be represented LM, where W is string such that from Q0 state for W string, and Z0 is the initial symbol for having multiple operations. You are approaching to Q1 state and string is exhausted, and that is the top of the symbol can be anything. The top of symbol can be anything. Here Q1 is the final state. By this way we can accept a string. I'm just repeating it once again. The language is such that it is a set of string where Q0, when machine is on Q0 state, and for consuming the entire string, initially the stack top symbol is the stack initial symbol, and finally you are moving to a state where that state is the final state. It is written that Q1 belongs to the set of final state and string is completely exhausted, and whatever the content left behind on the stack is immaterial for us. For those kind of strings, they all be accepted by this machine. So this is the acceptance of any string of the CFL with the help of push down automata. So let us see one another style to accept a string, that is acceptance by empty stack. So here you are seeing that we are having again the 7 tuple, but here we are not having any, we are having no final state. Instead of final state F, we are writing here 5. So there is no final state and the string has been accepted by the empty stack. So again we are having all the 7 tuple, but the last tuple which shows the set of final state, it is not F here, it is only 5. So here we are representing with the help of empty stack, and the language will be LM will be set of string such that if we start from Q0 state and we consume the entire, we start from the string and the initial top symbol is the stack top symbol is the stack initial symbol, and finally you are coming to some state Q1 state and string is completely exhausted, and that stack top symbol have been exhausted. It means the stack top symbol is now no more. Stack initial symbol has also been popped. So it shows that stack is now empty, and it also represents that the string has been accepted by the PDA. So let us see the same concept with the help of some examples. So we will try to solve this example by both the way. We will accept this string, we will accept this language AMBN with the help of empty stack, with the help of final state also. So example is AMBN. It means number of A's are more than number of B. Initially there are some A followed by lesser number of B's. There are some A followed by lesser number of B's. One very important thing is that once B start coming, then A cannot appear. Once B starts coming, A cannot appear. Number of frequency of A is more. So we have, first of all, we have to make its logic. So what will we be doing? Logic is very simple. We are having a stack and the stack top symbol. Initially we are having the stack top symbol, that is the stack initial symbol, which is Z0. So that stack is given to us. So for each A, we will keep pushing A onto the stack. For every A which is encountered in the input tape, we will push A onto the stack. And once B start coming, first of all we will change the state. And then for each B we will pop an A from the stack, and finally once the string is exhausted, there must be some A remaining on the stack. So this is our idea, and if this is the situation, we will accept all those strings. So here what we are doing here, so this is the initial state. You can write here the arrow symbol to represent that this is the initial state, Q0 is the initial state, and once Q0 is the initial state and stack top symbol is Z0, then B cannot appear. Then B here cannot appear. Then the initial symbol, it shows that the initial symbol can only be A. So if the A symbol is there and stack top symbol is Z0, what is happening here? We push A onto the top of the stack. If again A is coming and stack top symbol is A, we are again pushing A onto the top of the stack. But once B appears, so B appears means certainly there must be A on the top of the stack. It shows the transition like this. B is the input symbol and A is on the top of the stack. So what we are doing? We are simply popping A from the stack and we are jumping from Q0 state to Q1 state. Jumping from Q0 state to Q1 state it is necessary because it ensures that once B start coming, then A cannot appear. If we perform the same transaction on remaining on Q0 state, so once B is there, then after A can also appear. So it will be a wrong solution. So to avoid that kind of confusion, we are simply moving to another state, that is the Q1 state. Now again, if B is coming, so A must be on the top of the stack. We are again popping A from the stack. Now there is another transition. This epsilon means now string is exhausted. There is no element on the string. String is exhausted from the input tape. Certainly there must be some A on the top of the stack. What we are doing? We are again popping those A. Again, suppose there are again some A is there on the top of the stack. Again we are popping them. It means for all the remaining A which are there in the stack, we are popping all those A's. Right, and finally now here what is happening? String has already been exhausted. Now the stack top symbol is the stack initial symbol. Then again we are popping that symbol also and we are making stack empty. Here this symbol shows that stack is now empty. This transition here in this situation we are simply popping A element from the stack. It does not mean that stack is empty, but here what is happening? String has been exhausted and the stack initial symbol is there on the stack top symbol and that has already been popped. So it is ensuring that the stack initial symbol has also been popped. That means stack is empty. So once stack is empty, so it means we are accepting that kind of strings with the help of this machine. And this is the solution with the help of empty stack. So here we are representing the machine like this. Machine is having 7 tuple and the last tuple is the 5. There is no final state. In this complete transition diagram, we are having only 2 states, Q0 and Q1 state. There are 2 input symbols, A and B. There are only 2 stack symbols. We are pushing only A on the stack. For B, we are not doing anything. We were popping A. So we are pushing only A, and there was another special symbol, that was the stack initial symbol. So there are 2 toe symbols, A and Z0. Del is the transition which we have already make in this diagram. Q0 is the initial state, Z0 is the initial stack symbol, and phi represents that there is no final state. We are accepting, we are making this PDA with the help of, we will accept here strings with the help of empty stack. So let us see separately its transition functions. Transition, suppose we are on Q0 state, only A can appear when Z0 is on the top of the stack, and for that purpose we are pushing A, and if A appears and A is on the top of the stack, we are again pushing them, keeping on the same state. But if we are on if machine is Q0 state and B is recently red symbol, certainly at that time A must be on the top of the stack. We are changing the state and we are popping A from the stack. So here it is epsilon written here. Again now here we are on Q1 state. Again input symbol is B, so there must be A on the top of the stack. Again keeping on the same state, we are popping A from the stack. Now string is exhausted, there must be some A left behind on the top of the stack. If this is a situation, so what we are doing here, we are remaining on the same state. we are remaining on the same state, and we are simply popping A also. So keep on popping A also. Now finally, after repeating these kind of transitions, finally what will happen? We will be on the Q1 state and string is exhausted. Now Z0 is the initial stack top symbol. So we are also popping that symbol and we are making stack empty. So by this way we made all the transitions here. Now let us see how we can solve the same example with the help of final state. Here with the same way, suppose we started when the machine is on Q0 state. A is the input symbol, Z0 is the stack top symbol, stack initial symbol is the stack top symbol. We are pushing A onto the stack. If A, again another type of transition is if A is the input symbol and stack top symbol is A, so we are again pushing A on the stack. Now if B is the input symbol and A is the stack top symbol, we are changing, we are jumping to another state, that is the Q1 state, and we are popping A. Now again B appears, and there is A, again B appears and there is A on the top of the stack, so we are again popping A from the stack. Now string is exhausted, and suppose there are some A. We don't know how many A's are there on the stack, but this itself is sufficient enough to ensure that number of A is more than number of B. Now suppose for all B, when you are having A on the top of the stack, you popped all A's. You popped A. So number of A have been popped, it is equal to number of B. Now suppose string is exhausted and at the top of the stack you find some A. So it itself is sufficient enough to ensure that there are more number of A in the string. And once this type of situation is there, so we are moving to another state and we are doing nothing. We are also popping A also. Here what we can do, we also can perform no operation here, leaving A as it is. We can move to Q2 state, or we can pop it also, there will be no issue. And finally we are moving to the final state, and by this way machine will be like this. Machine is, now there are three states, Q0, Q1 and Q2 state. Input symbols are A and B, stack symbols are A and Z0, transition functions are del. Q0 is the initial state, Z0 is the initial stack symbol, and Q2 is the final state, and they are the transitions. They are the transition functions. You have already seen A is there, Z0 is the stack top symbol, we push A. If A is input symbol, A is on the top of the stack, we remain on the same state. If B is input symbol and A is the top symbol, we are jumping to another state, popping A from the stack. If again B appears, A is on the top of the stack, we remain on the same state and we pop A element. Here we are on the Q1 state and string is exhausted. A is there on the top of the stack. So what we are doing, we are moving to the final state, and we may pop this A or we may leave this A as it is. There will be no issue, but finally here we are moving to the final state. So that's all about this example, and we will continue with some more examples in the next video. Thank you very much.